6-2 alpha is anti-differentiation by substitution. Listening? That is an AB topic. So what we're going to do over the next 2 days is also look at the AB test. After that, we move on to 6-3, which is the anti-differentiation by parts. That is not on the AB test. So what we're going to do for the next 2 days, you can work with AB chart on to help each other. But at the end of the week, no. Because at the end of the week, what we're doing is specific only to BC. So, here's this question. What are we going to do? We're going to anti-differentiate it. What does that mean? It means x plus 2 to the 5th is the derivative. It's the velocity. You know what's being asked here? You want to find the area under this curve. No, it's an indefinite. Area of the curve that's that tall and that wide. So we're going to do the power rule in reverse. Well, what's mu about? Well, if we were doing the chain rule, we would call that mu. When you look at this problem, the derivative of mu with respect to x is just a 1. So we do the chain rule, but we're not going to notice it. So we rewrote the question as, instead of this this 2-term expression, x plus 2 to the 5th, we just said it's mu to the 5th. Well, how do we anti-differentiate that? But look what they did. Ready? This question, x is the input, dx is the width. This question, mu is the input, du is the width. Okay, as long as they match, we're good. And we get power rule in reverse. This 5 gets replaced with 5 plus 1, and then we divide by that. Okay, so if we back up, we're going to say take the derivative of this thing. The derivative of this, we would say 6 times 1/6 mu plus 0. And the 6's would reduce. Yes. So we get back to where we started. So what's happening is when you do the power rule in reverse, when we do the power rule, first thing you do is multiply the exponent out front with the coefficient, and then you replace the exponent with 1 less. When we do the power rule in reverse, we undo the addition under the subtraction first, and then undo the multiplication. So to undo the subtraction first, we replace 5 with 5 plus 1, and then we divide by that value. We would get 1/6, mu to the 6. Now, you've got to be careful. There was no mu in the question. So we've got to rewrite our answer in terms of what that was, which is x plus 2 to the 6, divided by 6, plus the constant. We need a constant because there were no upper and lower limits. If there are upper and lower limits to the integration, the constant is essentially optional. But the constant is subtract to 0 anyway. When I say it's essentially optional, like if you were an AB next year, you know what I'm talking about. You don't need the constant if you have upper and lower limits. If you weren't an AB next year, you need the constant all the time. So you understand what I'm saying? We'll get the hang of that. I'm suggesting to people who did this for months. Here's a different question. Now, here's the question. Ready? Well, what am I going to call my mu? It's the same thing we differentiate. What is in the parentheses would be your mu. In that section parentheses, it's really 1 plus x squared to the 1/2 power. So this problem's different. What do you got? Mu equals what's inside the parentheses. So I have mu to the 1/2 power. But now what? du dx is 2x. You have the 2x. So all of this goes to du. So now these match up. See, the variable, the height depends upon, matches up the variable the width depends upon. You started that way and ended that way. So now you do this. Replace the 1/2 with 1/2 plus 1. You get 3/2, divide by 3/2, the same as multiplying by the reciprocal. And then you turn around, you can't leave the mu in your answer, and you paste back what it equals to. So you would get 2/3, that's what mu is, to the 3/2 plus the constant. So what the difference is between those two problems, and these aren't in the book, this is from the second edition of the book, and it's bringing some other problems in there. The first one you saw, du dx was 1, the identity element. In this case, it wasn't 1, but it was sitting way outside it. Parentheses. Like people say, well, where did the 2x go? It didn't go anywhere. 2x dx is your du from over here to the right. See, they skip a line here. It's really du dx equals 0 plus 2x. And they say du equals 2x times dx. It's an artificial problem. It's like factoring. Ready? If you factor a cubic, you factor a quadratic, it's only going to work because it's built to work out. This only works because it's built to work out. Okay? It's giving you an opportunity to just practice the technique. If you did not have 2x down here, you would have to go here. So, you don't have this, but in the textbook, Gary has it. Gary, tell everyone, please, if you're home or in the room, what is on page 612 of your textbook? It's a brief table of angles. Tell us, Gary, how brief is it? 140. There's 140 of them in there. Meaning the back of the book, they give you the work for the problems that don't fit like this. That's just a brief table. You don't have to worry about what's in the back of the book. I mean, the ones in the first page kind of help you get started. It wants to deal with trick ones. But it's rare. Like I said, it's artificial for this to work out. You got to be able to work with the artificial questions before you get to the more challenging questions. Right? Moving forward. This is the first time we have to do some work. Okay? So this question says, let's anti-differentiate that function. The function is root four x. That's not good. It's not good. Right? It's square root of 4x, take away 1. So I said, all right, let's start with it. This is the mu. What's in the parentheses? We're just saying That's really mu to the 1/2 power. Yes? So d mu dx, so right over here, d mu dx equals 4. So d mu is 4 dx. I don't have 4 dx, I just have dx. Do we recognize the problem? So now what? Well, this is how they do it. I'm not going to do it this way. It's up to you. You can do it if you prefer this. Based off of dx. I'm going to say this. I'm going to say you got mu to the 1/2 dx, which is a problem. Now I want to anti-differentiate that. Well, I need this to be du. So if I put a 4 in here, 4 dx is du. But if I put a 4 there, you have to put a 4 out front to balance it. Okay? You're going to get the same place as the power point. I just personally prefer what's on the board here. Try and give you a shot of here at home. That instead of doing the work on the PowerPoint, we wrote in red, anti-differentiate mu to 1/2 dx, but you can't do it. For it to be mu to 1/2 du, you need to multiply dx by 4. And you can do that, as long as you multiply by its reciprocal out from the integral. Then you, in fact, what's in blue is multiply by 1. So now what? You would get mu 1/2 plus 1 is 3/2. Divide by 3/2, which is multiplied by 2/3. Now I have the 1/4 out here. So you have 1/4 times 2/3, right? You have 2/12, which is 1/6 mu to the 3/2 plus your constant. Except there was no mu in the question, so you have to go ahead and paste what mu equals to, and that would be your answer. So these problems just progressed. And what you need to do is come back to this PowerPoint at your own pace. This is going to be something that is like over your head. Not over your head in too hard, but something you have to deal with over the break. Oh, I need a rest. I got to need a rest. You have ways to rest. What you need to do is, between Christmas and New Year's, revisit the stuff. You give yourself, half a week off. Fine with it. If you give yourself a week and a half off, then you're going to have major issues coming back in January. So this is what we're doing. We're doing anti-differentiation. So for you to go to, I gave you this organic chemistry teacher, right? Yeah. So I'm going to put that link on campus. I was looking at it. Right? So we'll put that link on campus. You have been using that. You're going to have an exit ticket. It's going to deal with your New Year's resolutions about what you're going to do to make strides towards your goal. So over the break, you say, okay, you know what? This thing didn't make sense to me. We're doing at the end. I'm going to look at your cities. I'm not telling you not to start that all kinds of homework. I'm saying you got to find something that, an explanation that's effective for you. What about this question? Well, I can anti-differentiate cosine, yes. Because cosine is the derivative of sine. But the problem is the mu. So we write it this way, we say, okay, mu is what's in the parentheses. So d mu dx is 7. So d mu would be 7 dx. And a lot of people are writing stuff down, which is fine. I'm not going to micromanage how you process this, but I would say this. You don't need to write down a problem. Like if you want to write down the third problem, these are just getting progressively more challenging. So if you were to write down a problem like 2 examples ago, you're like, well, this moved beyond that. It's not very helpful to me. So here's the question. So what are we going to do? We're going to rewrite it as anti-differentiate cosine mu. But du dx is 7. So I got dx here, I need 7. So I'm going to put a 7 there, and I'm going to put a 1/7 out front. It's a little different than what they did it in the PowerPoint. You're going to get to the same place. Cosine is the derivative of sine. So you have 1/7 sine mu plus the constant because it's indefinite, and then you paste in there what mu is. So why this PowerPoint is helpful is you just have these series of questions that get increasingly more challenging in terms of substitution. When we call this anti-differentiation by substitution, the substitution is the mu. You're substituting mu, what was in the parentheses, that's what we're talking about. But in order to do the problem, the variable that the width is based on has to match the variable that the height is based on. So, like they said, not in the book. Yeah. When you introduce something, you may not, cannot, will not introduce a variable. Okay? All you do is introduce constants. So take a look at this question, and you, ready, we're going to leave this up here without rolling it in. You start your question. Same thing if you're at home. You just want to begin the problem. You want to anticipate what the next 2 slides are going to look like in context of what you did on the other problem, or the problems you watched before this. So mu is x cubed. So d mu dx is 3x squared. So d mu is 3x squared dx. What have I got? I've got x squared dx. So if I put a 3 here, then this is the d mu. But if you put a 3 there, you've got to put a 1/3 out front to balance it. Meaning what? The only way to proceed in this problem was because you had x squared dx. If this question was x times sine x cubed dx, dead end. Where would you go? You would go to the variables, brief table of intervals in the back. So again, this problem was set up for you to succeed. So we get 1/3 sine mu because the 3 x squared dx is d mu. Sine is the derivative of negative cosine. So you're here, and then you turn around and put what mu equals, which is x cubed, and you're finished. Really? Yeah, right? They did it a different way too. So we would be fine, without seeing what you did. This isn't the only way to do it. Personally, like people, I'm not really worried about people that saw this year. You've never seen this before. I want you to stick to the way that I'm showing you, where I'm putting it. I'm saying this thing here, 3x squared dx is d mu. Which I need here to do this. So I introduce a 3, so I have to introduce a 1/3. With a balance. Okay? If this was, so here's my point. If the question were, anti-differentiate x sine cubed dx, you say, okay, I need 3x, because the root is 3x squared. 3x here gives me 3x times x, 3x squared, 1 over 3x here. No can do. You cannot introduce variables in this, only constants. Okay? One more. Then we'll go to the textbook. Now, does this make sense to you? What are you going to call mu? It makes sense to call mu sine x. Why? Because you have d mu. Because remember, sine is cosine. That make sense? Like you look at this thing like, oh my God, where would I start? I got this product. No, that's part of your d mu. So the problem just becomes mu to the 4th d mu. Where'd the cosine go? The cosine is part of your d mu. Your d mu is cosine x dx. So now you just anti-differentiate. Mu to the 5th divided by 5 plus the constant. What's mu? Mu is sine x. So we skipped most user-friendly questions in the textbook. Because I'm starting the PDF with example 4. So we just go back to the book. This is on page 332. Now, we're not going to write this down. Properties of indefinite image. Well, right here, this is the power rule reverse. And it says, when n is not equal to -1. Because if n is equal to -1, when you add 1 to it, you would get mu to the 0 divided by 0. So when it's -1, you have to go over here, which we did before, but we will connect that to it. Here are the trig formulas. This is the work that you're going to have to be able to do. Like we go back to the section in chapter 3 about derivatives and logarithms, derivatives and exponentials, and undoing that. This is where this gets later. All right, so we're going to pick up with one of the harder examples. Here's what you got. This is in your book. Sine x times e to the cosine x dx. What's going on here? Well, if you rewrote this problem and say mu is cosine then d mu dx is negative sine, and d mu is negative sine x dx. So the way I wrote it on the PDF is I put that line in there that they were skipping on the PowerPoint. The differential. So then I'm going to rewrite the question as e to the mu sine x dx. Well, I need negative sine x dx for my d mu. So I multiply -1 inside and outside the integral. -1 times itself is +1, which is the identity multiplication. So you would get -1 times the antiderivative of e to the d mu. You have this. Negative e to the mu, because its derivative is itself. Negative e to the mu plus the constant. And rewrite that as negative e, what mu is, cosine x plus the constant. Okay? So that's your model. You're going to problem number 19. So if you're at home, that's what you're doing. You're going to 19. We'll go over that, and then we're going to send you to the exit ticket. One minute. Now, if you find this confusing, that's a good thing, because it is going to be confusing. You have to allow yourself to make mistakes. No one cares if you don't answer problem 19. You care about you getting steps consistent. So, go ahead. Here's 19. Ready? You got secant this and this. You got it? Well, mu is 2x. So the derivative of secant is secant tan. When you anti-differentiate, it's going to take you to secant. Except what? You need 2 times dx to give you du. So you've got to put a 1/2 out front. So you would 1/2 secant mu plus the constant, and you would get that. Because what you recognize is, the question was secant tan. And secant tan is the derivative of secant. I'm looking, you can remember that, on page 332. So, if you are at home, it doesn't matter whether you're ADP, if you are ADP, you miss out on candy. But it doesn't matter whether you're ADP or you're a Tuesday child, you're dismissed, you're 8-week class, and the exit.